Hi, hello everybody.
Hi, hi,
So
hi. Yeah,
just wait for let's wait for a couple of seconds so that I can just assure everybody is in the meeting whom we want. So we have Rajdeep, that's me. We have Aarti, we've got Hemant, we've got Morgan, and we've got Rima. Okay, so it looks like we have everybody in this classroom right now. So let me introduce myself. My name is Rajdeep Singh. I am a student teaching assistant here at the City University of Seattle. Currently, I'm pursuing Master's of Science in Computer Science, and I'm in my last quarter right now. So probably this is the last time you're hearing me talk like officially as a student here. So a warm, very warm welcome to everyone out here. So we'll do this session. Please start recording, Harrison. Okay, sounds good to me. Just a second. I'll just pull this recording for a second. Just a second. Mm, it's audio. 1 second. Mm. Hemant, would it be possible if you can see the record button on your screen? Is it possible that you can see and turn it on?
record button. Yeah, I can see, but it's started automatic. Yeah, it's
It
turned on.
started automatically. Perfect. Then we are recording it. Okay.
Okay.
So Hemant, Aarti, and Rima, we'll do it this way. This session that one by one you'll start presenting your screen. Sharing your video is optional but highly recommended because the session will be recorded. And this is for your CS687 capstone for your Masters of Science in Computer Science. I think I know all of you. You've been my classmates sometime or the other. So yeah, let's begin the session. I think Hemant, you can go first. So please present your screen, and
Okay.
the normal flow should be like introduce yourself with your instructor. Start off with the
Mm,
slide. Go through the entire presentation.
okay.
Let's keep it a cap of 15 minutes. You can go up to more, but let's keep it around 15 minutes or so. And in
Okay.
the end, if there are any questions, whoever is in the room right now, let's say we've got Morgan along with me, we can ask not just us, the peers, like while you're doing it, Aarti or Rima, you guys can ask some follow-up questions. And yeah, we are looking forward to your presentation. So go for it. And a very big congratulations to all three of you for reaching this point and having done this entire capstone major project for Master of Science in Computer Science. Thank you. Yeah, Hemant, you can
Yeah,
start now.
yeah. Thank you, Rajdeep, and wishing everyone all the best and congratulations to you all. Okay. Yeah, I'm just starting my presentation.
Mhm.
So, my name is Hemant Donikena. My advisor is Teji Kim, and my project title is Healthcare Symptoms Insight Assistant Safe Generated AI. So today there is a large amount of healthcare information available in online, but it is often difficult for users to interpret correctly. Many people rely on the search engine, so or unverified sources, which can be lead to confusion or misinformation. Generated AI models can be help explaining symptoms, but they may be sometimes produce inaccurate or illusion response. To address this, I developed a retrieval argument generator like a RAG based on healthcare symptoms insight assistant that provides reliable grounded information using trust medical source. So this is a agenda for today presentation, and this is a problem statement. So how can AI chatbot provide reliable, safe, and symptoms information without causing confusion or unsafe health decision? So the main problem in how AI chatbot can be provided reliable, safe symptoms information, so without causing confusion. So unsafe health decision executing tools either providing uncertainization results or unsafe AI generated response. And second one is fourth slide motivation. So online symptoms checker can be give unsafe, inconsistent symptoms advice. Generated AI may be produce comfort but incorrect symptoms, and users may be overtrust symptoms output delaying professional medical care. So there are three main issues. The first, online symptoms checker can give inconsistent or unsafe advice. Second, generative AI may be produce confidently but incorrect answers. Third, users may be overtrust these systems can delay professionally medical care. So fifth slide is background generative AI. So AI can be generated human-like text in healthcare in explain symptoms but may sometimes give incorrect overconfidence answers. And LLM, like large language model, advanced AI model trained large amount of text data. They needed safety controls when used healthcare systems. Symptoms checker, tools that provide health information based on symptoms entered by users. They are meant for education, not diagnosis. And hallucinations. So when AI gives confidence but incorrect information, this is any important safety risk in healthcare AI. So in AI generated like human text, but maybe sometimes be incorrect, and LLM are powerful but need safety controls. Symptoms checker are also for education but used but not diagnosed. But hallucinations is when AI gives confident but wrong information, which is major risk health information. So and for relative work, so these are the table, so which is a primary focus, safety risk in AI symptoms tools, and second one is a medical resource of LLM and trust transparent in healthcare AI. Second one is like a user safety, hallucination, overconfidence risk, limited safety focus, exporting information safety, and expandability and poor unclarity communication, minimum expanded center of focus of XAI, and user of LLM, like a limited generated AI users LLM, no LLM use, and relevant to project, support non-diagnosis boundaries, motivation control LLM use, support explainable symptoms inside. So this previous study shows that AI is healthcare protein portability, but in risk hallucination, lack of transparency, overconfidence. This studies highlights the need, the safety of explainable. This is a AI systems for the related work. So and for approach like a RAG, so I collected trust medical data from MedicPlace plus APIs. Then top K Victoria retrieval section, relevant medical information. So I applied a retrieval argument generated when adding safety layers detected for red flags symptoms. So which is I used for approach. Slide 8 approach and proposed approach in see the safe. Okay, so so this is the comparison between related work and plus approach. So this is the proposed approach. The safety can be examinable AI symptoms inside systems using RAG and red flag detection, non-diagnosed symptoms guidance. So grounded response using retrieval medical source and LLM retrieval argument generated. So I mean retrieval argument generated. So combines RAG safety checks and trusted medical data for the safety patient education. So this is the difference between relative work and approach section. So this is a design which safety first, grounded generators and expandabilities and modulations. So design this slice highlights the key design principles. So I followed while building the rack based on healthcare assistant. So ensure that the system is used safely, reliable, maintainable. Safety is the most important principle in my systems. The chatbot does not provide diagnosed or pre-subscription treatments. Instead of it focus on generally guidance, clearly highlights when user should sneak the professional medical care. So I also for emergency symptoms insert relying on only on language model. So I use RAG approach, the system retrieval the medical information first and the users as a context for the LLM. This reduce hallucinations and ensure that response are grounded in the real medical data. These design principles ensure that systems is not only function but also safe, transparent, and scalable for a real world healthcare applications. So implementation, so which I use VS Code, a powerful code editor, and OpenAI's and Streamlit and medicals plus data sets. So which is I use implementation in my project. So and for data collection, so I collected data for trusted medical websites such as MedicPlace and source of dataset 20 common healthcare conditions from diagnosed categories. So information collected. So collected name, description, symptoms, and safe care advice, warning signs when the sneaking doctor for a source of link, and collected method information was manually derived when collecting from the official health pages. So data organization, so which data are structured in Excel, Google Sheets, and exporting as a CSV file. So this is the data analysis. So retrieval, accessory, grounded score, safety comparison. So which is retrieval accessory is 87%, grounded score is 90%, and safety comparison is 95%. So I tested this system using different symptoms queries, including both normal and high risk. So the output was evaluated by accuracy, grounded, and safety. So this is a retrieval evaluation. So the system demonstrate strong performance across the key evaluations meters achieving. So 87% retrieval access and 90% grounded quality and 95% safety comparison during evaluation. So compared to traditional generated models without RAG, the the purpose of system shows significant improvement and reliability and safety. So these are the graph which traditional LLM versus RAG system, which show the percentage like a retrieval accessory 62%, grounded score 55%. The safety comparison is 70%, the RAG system 87%, so 90% and 95. So these are the difference between LLM versus RAG system which use on healthcare. So there is a one evaluation, the output I used for any other LLM model. This is called as a evaluation is known as a judge model. So conclusion, so AI can help healthcare, but it also has risk like wrong information, overconfidence, and lack of experience. Because of this, patient's AI system should not give medical diagnosed. So this idea guided that healthcare symptoms insight assistant, which provide non-diagnosed symptoms guidance, clearly explain and information from trust medical source. So which is Medicline and APS, that is my trust medical source. So this is the future work. Expanded the knowledge based on evaluation of system using large data set, real user studies, and improving reliability. So improving system futures by adding better explainability and multilingual support and possible integrate which clinic decision support systems while in maintaining the safety limits. So in the future, I plan to expand data sets, test and real users. Like I will also improve expandability and adding a multilingual support system. So explores integrator which clinic systems. So this is a demo. So I like to show demo of my. So this is the dashboard of my healthcare insight assistant generated AI. So we have example symptoms and the settings and top care retrieval topics and minimum reference. So I can adjust the relevant topics into 3 to 8 level and minimum reference also I can increase from 1 to 10. So while user enters symptoms like I have a fever and cold from past 5 days. So when user have symptoms, they want to check. So once they will enter the prompt like have a fever and cold from past 5 days. So once generate the response, so it will show the related topics. So which is what could be related to fever and cold symptoms from last 5 days, could be infection or common flu diseases. So it will show the say general self-care, which is you to say hydrate or not, and which is a source. So I took from links. So it will take me to the source, which is the correct response for medical and place, which is this is a reference which cold fever, like I'm suffering from 5 days, it will show the correct reference, the source, so we can trust this medical source. So once done, like a user want to check in any other medical condition, so simply we need to go and just clean the chart and type it again, like have a stomach pain after eating today. So once I go to generate a response, so it will give the response of generated, so which is I'm suffering from the stomach pain. So this could be the related work, I mean, related to topics while suffering from the stomach pain. So it will show the general care. And once I enter this source of evidence, it will take me the source of links from the medic place. It is the actual results. It will show the why I'm suffering from the stomach pain. It will take me to there. So which so these are the reference which I'm using the source. So this is all evidence for the resource which I'm pulling data from medical line. So medic plus. So after that, once it's done, we can clean chart and just put it over. So this is all about my healthcare symptoms. So actually, it's not diagnosed; it's only for the symptoms checker. So those who are, I mean, those who are don't go to the hospitals and they just want to check what symptoms I've been suffering from. So they simply just type it and they check the symptoms. That's it. And so this is the system evaluation of findings. So this is where no rag versus rag I generated. I mean, I compare with them. So to evaluation the effectiveness of system, I compared response generated by standard LLM without LLM, retrieval argument response used on RAG approach to evaluate the efficient the system. I compared response generated by standard LLM without retrieval against response. So the RAG approach, which query was tested using both approaches, and the response were evaluated across the multiple dimensions, including relying on grounding, safety, hallucination control, clarity. I also included comparable judgment to identify which approach performed better. So in the table, A represents a non-RAG response, B represents of the rank based on the response. So the judge winner, the column shows which response performed better or which query talks about grounding. So key differentiations of one major difference is grounding. The RAG system uses retrieval medical documents. So it is response directly supporting by trusted medical source. The non-RAG module, on other hand, relying on only it is inter knowledge, maybe lag of criticism. So hallucinations can control RAG significantly reduce the hallucinations because the model is concentrates is using related retrieval context. Without RAG, the model may be generated possible but unverified information. Safety, both approaches maintain the safety to some executed, but RAG provides more reliable safety guidelines and reference reliable safety guidelines. So these are the reference for medical source and including structure of when to seek the medical information care. So this is the I compare with GPTI versus my dashboard. So it show the relevant answers. So this is B is the main winner, like it's my dashboard. So this is A. I got little bit wrong answers, but for the B I got accuracy. So this is only for symptoms care, which is reserved only for symptom checker, so not diagnosed. So this is all about my project, and this is a reference. And yep. So any questions? And thank you for your attention.
Thank you so much, Hemant. A big, big, big thank you, and congratulations for this entire work that you've done.
Okay.
So apparently, I have one question for you
Okay.
because during the time you were showing those evaluation matrix, right, of the traditional LLM versus the RAG that you have made, where the RAG was exceptionally performing well, like 47% to 99%. That
Yes.
was the growth. So when you mentioned the evals, and you also mentioned that you used LLM as a judge for the eval, am I correct?
Yes.
So, did you think of any other approach for eval, like having a human in the loop or writing unit tests, or how did you come to that point that hey, using LLM as the judge is my best option?
So basically, LLM can give incorrect hallucination response for the RAG. is improving accessory relevant information trusted medical source before the generated response. So basically LLM can be incorrect, but RAG can give me the trusted source, which is I used third party of LLM, or I mean third module of LLM. It is the evaluation of known as a judgment module. I mean, we can call judge module for the LLM evaluation, the third party of module.
Got it. So apparently, what I understand, along with your LLM, you had a RAG from where like relevant data was being retrieved to give the accurate answer with no hallucinations, and in order to check whether this answer by the RAG is correct or not, again you used another LLM to verify the response. Am I correct?
Yes, yes, I'm user. Correct.
Perfect, perfect.
Yeah.
Thank you so much, Hemant. Like, yeah, that was my question.
Okay.
Rima or Aarti, do you guys have any questions for him, or should we move forward?
I am good.
Okay. So probably since you unmuted yourself, so Rima, probably you can go next. Once again, Hemant, thank you so much for your time. Probably you can stay here till the time your peers are also giving the presentation, and yeah,
Okay,
let's
okay.
see how it goes. All the best, Rima.
Yeah, yeah. All the best, Rima and Aarti.
Thank you so much, Hemant. Thank you so much, Rajdeep. Okay, I'll present my screen. Let me know if you guys are able to see my screen.
Yup, it's visible. You can start.
Yeah, yeah, I can see.
Oh, just give me a moment. Uh,
Rima, just a heads up, I can see your notes, so maybe you can
oh,
turn
okay.
this mode off.
Yeah, you can use
1 minute.
that present in Teams.
Okay, 1 second.
Yeah, save it, save it.
Okay.
Just wait. Save it. Wait for
Hemant
one
knows
minute.
everything about this hack.
It will go live. And yeah,
Yeah, it's visible now, and I cannot see your notes. You can start now.
Perfect. Okay. So, yeah, hi everyone. My name is Reema. Uh, my advisor was Shiva Kumar, Professor Shiva Kumar, and my project is Pharmaceutical Inventory Optimization Platform for Healthcare Networks. Basically, this project focuses on how AI and data-driven systems can help the hospitals to reduce waste and avoid medical shortages. This is the agenda for today's presentation. I'll be covering all these topics. The motivation, the scale of pharmaceutical waste and preventable shortages highlight a critical gap in healthcare inventory systems. Each year, more than 4.5 billion is wasted globally, and hospitals lose around 150K dollars to 250K dollars annually due to expired or mismanaged medications. About 23% of the drug shortages are preventable, but most systems lack real-time visibility across the facilities. Beyond cost, pharmaceutical waste contributes to environmental risks. These challenges motivated the development of an AI-driven platform. The problem statement. Despite all the efforts we put into healthcare supply chains, we still see the same problem, waste and shortages happening at the same time. So, why does this happen? In the current systems, they rely on static forecast and manual tracking, ignoring how the medications expire, unpredictable demand, or the possibility of moving surplus stocks where it's needed the most. The real gap is the lack of an integrated platform. There is no system providing a live multi-facility view or AI guidance to make the smarter decisions in advance. Let's move on to the background. When you go to a hospital or the pharmacy, you expect your medication to be available. But behind that expectation lies a very complex pharmaceutical supply chain. There are four major challenges that make this problem difficult. The first is pharmaceutical inventory. It directly affects uh, it it directly affects the patient's outcome. It's not just a logical issue, but it's a drug availability and it affects the patient's safety, treatment continuity, and healthcare cost. The second is the supply chain itself, as it is highly complex. Demand can fluctuate significantly depending on the patient's need. The third is the hospitals lose significant value each year due to drugs expiring before they are used. Much of this happens because existing systems are reactive rather than predictive. The fourth one is the drug shortages occur frequently. Most current systems rely on static historical averages when each makes it difficult to respond to real life challenges in demand. Uh, let's move on to the synthesis matrix. The synthesis matrix summarizes the key insights from the literature review and highlights an important uh, research gap. So across studies, we can see that many researchers focuses on individual aspects of the pharmaceutical inventory management. For example, some papers focus on demand forecasting using AI and machine learning, others address perishable inventory optimization, and few explore supply chain coordination. However, most of these approaches are isolated solutions. They either operate with a single hospital environment or focus on one specific optimization technique. What's missing is comprehensive platform that brings these capabilities together, combining predictive analysis, expiration management, and cross-facility coordination in a single operational system. So my approach aims to fill this gap by integrating AI-driven forecasting, multi-agent decision frameworks, and network-level inventory coordination into a unified platform. This is my feature list. I tried to implement four of these. Um the first one is the expiration management. This feature identifies medications that are approaching expiration and recommends proactive actions such as prioritizing usage or redistribution to the facilities where the medication is needed, helping to reduce waste and financial loss. The second is the multi-facility coordination. Healthcare networks often have surplus inventory in one location while another facility experiences shortages. This feature matches excess inventory with demand across facilities to enable efficient redistribution. The third is the demand forecasting. This system predicts future medication demand by analyzing historical usage patterns along with external signals, helping hospitals plan inventory more accurately and prevent both shortages and overstocking. Finally, the decision support analysis. Real-time dashboards provide visibility into key metrics such as inventory levels, expiration risk, forecast trends, and transfer opportunities, allowing healthcare administrators to make faster data-driven decisions. This is the solution architecture. This architecture shows how the platform integrates data, AI agents, and analytics to support intelligent pharmaceutical inventory decisions. On the left-hand side, you can see data from multiple sources. This data goes through the normalization and enrichment before being stored in the stored data warehouse. Next, the system integrates contextual domain data and external APIs, which provide domain intelligence and additional context for decision making. At the center of the architecture is the Crew AI multi-agent orchestration layer. An agent coordinator manages collaboration between specialized agents, including the expiration agent, forecasting agent, and the transfer agent. These agents analyze demand patterns, detect expiration risk, and evaluate redistribution opportunities. Their decisions are supported by shared agent memory for context and coordination. Finally, on the right-hand side, the system generates outputs such as expiration mitigation actions, optimized transfer orders, and predictive replenishment plans. These insights are visualized through interactive analytics dashboard, which help the healthcare administrators modify inventory risk and make the data-driven decisions. So the approach of this platform is a multi-agent decision framework designed to automate complex pharmaceutical inventory decisions. At the center of this framework is a supervisory or the coordinator agent, which manages the workflow and coordinates communication between specialized agents. Each agent focuses on a specific task. The manager agent analyzes inventory data to identify medications that are expiring and recommends action to reduce the waste. The forecasting agent predicts future medication demand using historical usage patterns and forecasting models. The transfer coordinator agent evaluates inventory levels across the facilities to identify opportunities for redistribution. By combining these three agents into a collaborative framework, the system can automate complex supply chain decisions, reduce manual analysis, and provide transparent, explainable recommendations for healthcare inventory management. The implementation. This platform was implemented using the Python 3.8 Plus with a fast API for building secure REST APIs and orchestrating agent services. Data is managed using the CSV files for synthetic pharmaceutical records processed in memory and with pandas data frames for fast querying and analytics. For production deployment, SQLite provides persistent storage. The system includes data ingestion pipelines that handles normalization, validation, and feature engineering for over 150K pharmaceutical records, including inventory, transfer logs, and demand history. These pipelines ensure data equality, consistency, and readiness for real-time analysis, which is critical for the agents to generate accurate, actionable recommendations. Next, the platform uses a Profit for 30-day demand forecasting and ARIMA for time series patterns, including seasonal trends and demand fluctuations. It also applies anomaly detection to identify unusual spikes or drops in demand. A Crew AI multi-agent system automates decision-making where agents collaborate through a central orchestrator. This is powered by LangChain with GPT-4o, and outputs are validated using Pydantic for reliable results. Overall, this enables automated, scalable, and explainable decisions for transfers, reorders, and disposals in real time. This is the use case diagram. It supports multiple users across the healthcare network. Hospital staffs can manage inventory actions like transfers, reorders, and disposals. Operators can run forecasting, optimization, and monitor system dashboards. The finance team can track cost, waste, and system level alerts. Administrators can manage system configuration, medications, and supplies. The data flow. This process starts with the data ingestion, where inventory, demand, and transfer data from multiple facilities is collected and prepared for analytics. Then the multi-agent system works in parallel. The expiration agent identifies at-risk medications, forecasting agent predicts the demand, transfer agent evaluates redistribution option, the central coordinator combines all the outputs and generates the final actions like transfers, reorders, or disposals. These results are displayed on the dashboard, enabling real-time automated decision making. The next is results and findings. The system analyzed over 2,500 inventory batches and identified around $1.2 million at risk inventory, generating 288 actionable recommendations into reduce waste. It also found 15 transfer opportunities with about $27K in potential recovery, improving redistribution across facilities. For demand forecasting, it flagged 10 critical medications and achieved around 17.9 MAP accuracy. Overall, the platform enables efficient data-driven decisions, reducing waste and improving coordination. Let's move on to the conclusion. This project developed an AI-driven platform to address medication, expiration, stockouts, and inefficient distribution. It combines predictive analysis, a multi-agent system, and dashboards for data-driven decision making. The system successfully identifies risk, forecasts demand, and optimizes inventory across the facilities. By automating workflows, it reduces manual effort by ensuring transparency. Overall, it demonstrates how AI can reduce waste, improve efficiency, and enhance the healthcare supply reliability with strong potential to scale using real world data. The future enhancements. First, integrating with EHRs and hospital systems can enable real-time data and automated decision making. Second, using reinforcement learning can help dynamically optimize inventory decisions based on changing demand. Finally, the external signals like disease trends and weather can be directly incorporated into forecasting models, allowing predictions to adapt the real world events. Now I'll show you the demo. Are you able to see my screen?
No.
Okay, 1 second. Is it now visible?
Yeah, it's now visible.
Okay, perfect. So this is the dashboard for my project. Here, as I mentioned, there were three agents. The first is expiration risk, transfer coordination, and the demand forecast. Let me click on the expiration risk. So once we go here, we have expiry horizon, like we can see the data for the next 7 days, next 30 days, 90 days, 180 days. If we go on the 30 days, we can see how much value is at risk, how many items are expiring in the 0 to 30 day period, and we can see which hospital has how many medications that are about to expire in that horizon, and the risk by category, like 21.8% of antibiotic medications are going to expire within that period, and so on. We have all the medications with the cost and the batch value, and what is the risk level. Here we can see the batch ID, the medication name, and at which facility the medication is going to expire, how much quantity they have, and how much days it is left until expiry, and the batch value. Here, the agent recommends that there are 135 critical items. It recommends 50 transfers, 85 disposals, and it gives a saving of this much value. Like if we transfer uh, those medications, we'll save this much amount on those medications. Here, the AI also recommends which medicines should we dispose and which we should transfer. Here is the decision that the AI shows, like we can see for transfer how much 8 days until transfer we can transfer this, the cost, how much will it take to transfer, and the logistics cost, and so on. We can see the dispose reason as well here. So, cost benefit analysis, it identified total 10 cost saving opportunities with this much of saving. If we transfer the 10 medications immediately, we can save a return on investment of this much dollars. So this is the batch value, like the 10 medications that were shown. It is these 10. If we transfer this, we can save this much value. Let's move on to the transfer coordination. So this also has a timeline of next 7 days, 30 days, and so on. If I select the next 30 days, it shows the potential savings, how much will be the transfer cost, and what is the cost benefit ratio. This graph shows which facility has the excess medicine and which has the shortage. So based on that, we can also see, like, if I select this facility to this facility, it will show the medications route and the value on this medications, like this much transfer cost and the savings if we transfer from this facility to this facility. We can see what medications we have to transfer. I'll select all facilities for now. So top 10 routes, like if we go from this east side regional to downtown, we can save this much of value. Top medications by transfer volume, medicines that have the most units, we can save this much. Pending savings at risk. So these are basically the medicines which are not yet approved. If we approve these transfer of medications, we can save this much of money here. The AI then proposes the transfer proposals. Like um, if we transfer the medications from Central Valley Hospital to East Side, which medication, the quantity, the cost, how much will we save, and what is the return on investment? And uh, it also gives what reason is behind this transfer proposal. Like due to the demand spike, we are transferring warfarin from this hospital to this hospital. So next, on what basis the AI is giving this recommendation? Like if the return on investment is more than 5x, it will approve the transfer. If it is in between 2 to 5x, it will hold. It will review the transfer, and if it is below 2x, it will hold the transfer. Next, moving on to the demand forecast. Similarly, it also has the forecast horizon. The total forecast demand is this much. Like we can change the forecast horizon and we can see how much demand it is in the 14 day and so on for each medication, each category. These are the top 12 medications uh, colored by urgency. Like insulin, we want it urgent. The units, how much units we want. Then this is the forecast urgency tier, like 15% we want the medications are in critical state, it is 15.7% and so on. So the demand forecast, it predicts that 25 recommendations across 25 medications, the accuracy is 82.1%. And here also it recommends, like this medication, it is in critical stock storage, as the current stock is 688, the minimum safety stock is 2109. It is like the current stock is below the safety stock. So, and the forecast within the 14-day period, it is 648. So if we use it in the 14-day, it will be like near to zero. So it is recommending that we should rush order immediately. So it is under critical. So and also it generates the alert, like how much medications are in a critical state, how much are in high state, and how much are in medium state. So, yeah, this was my presentation also.
Thank you
Yeah,
so much, Rima. Really appreciate it for your time. You were a little
yeah.
off your clock, but still, like, that's
Oh,
totally fine.
I'm
I've
so
not disturbed
sorry.
you because your presentation was going really well. So I think you've explained it really well, and I don't have any questions as of now. So probably, is there anyone in the room right now who has any questions for Rima?
No questions.
Okay, okay, great. I think then we can move to our last candidate over here. Aarti, do you mind sharing your screen and starting a presentation for today?
Yeah, sure. Just give me
Before
a
that,
moment, please.
Rima, thank you so much. Once again, a big congratulations to you for completing your capstone project. Amazing presentation. Really appreciate it. Thank you for your time.
Thank you so much. Thank you so much, Rajdeep.
All the best, Aarti. Go for it.
Hi, is my screen visible?
Yes.
Uh, okay, great. Uh, Hi, I'm Aarti Ganesan. Today I will be presenting my capstone project on design of retrieval augment document question answering system for organizational uh, knowledge management under the guidance of instructor Tejan Kim. So, as in the title of the project, I have built the policy system using a RAG, where user can query based on the policy and get responses from the system. So, I'll walk through the problem, motivation, background, related work, and system design and implementation, followed by data collection, analysis, and short term of my project, and then findings, and I'll be concluding with the conclusion and the future work. So let's see about the problem statement. So organizations store large volumes of unstructured documents like policies and reports. Traditional keyword based search often fails because it depends on exact word matching rather than understanding the user intent. So, the key question is how can we move from the keyword search to a system that allows natural language queries and returns accurate context aware answers grounded to documents? So, while semantic search and RAG system exist, most do not handle enterprise constraints like access control, data sensitivity, and accountability. This project is motivated by the need of design a system that is not just accurate but also secure, trustworthy, and suitable for real organizational environment. So, the background. Prior research shows that semantic search and retrieval augment generation improve answer relevance. However, enterprise systems require more access control, transparency through citations, and realistic evaluation metrics. This project builds on those foundations while addressing these gaps. So, related works. I have reviewed over 15 research papers uh, with these three key studies forming the foundation of this work. So, Buchwald work shows that the traditional extractive question answering models, such as BERT based approaches, struggle with the long documents due to context fragmentation, which leads to very low accuracy. And more recent work of Karakurt uses retrieval augmented generation, which combines semantic retrieval and language models to generate more accurate and context-aware answers. These systems have shown significantly better performance. However, most existing solutions focus mainly on accuracy and do not address enterprise requirements such as access control, data privacy, and governance. This gap highlights the need for a system that is not only accurate but also secure and suitable for real world organizational use, which is the focus of this project. So, Now, moving on to the approach of this project. The system is designed using the RAG to enable intelligent document question answering over organizational data. So, unlike conventional RAG pipelines, the key innovation is integrating access control directly into retrieval stage, ensuring user only access authorized content. In the next slides, I'll walk through how this approach is structured and implemented step by step. So this slide provides an overview of my project built on insights from the three key research studies. The primary model I have used is Llama 3, is integrated within a RAG framework using ChromaDB. The system also incorporates role-based access control to ensure secure and domain-specific information retrieval. The main focus is on enterprise use case, particularly handling organizational policy and procedure documents. In the next slides, I'll walk through how the model performs based on key evaluation metrics. So the workflow begins with document upload, the pre-processing the document and converted into smaller chunks. Second, these chunks are transformed into embeddings and stored in a vector database for semantic retrieval. So the process is like when your user submits a query, the system applies role-based access control, then retrieves related relevant chunks based on semantic similarity instead of keyword matching. And finally, the retrieved content is passed through a language model which generates an answer grounded in those chunks. The system also returns the citation to improve the transparency and trust. Implementation. So the system which I have developed is implemented with Python as a backend using FastAPI, API, ChromaDB for vector storage, and PostgreSQL for metadata and access control, Olama with Llama 3 for local interface. The pipeline includes the document ingestion and embedding, access control and semantic retrieval augmented answer generation, and response delivery and logging. Data collection. The dataset consists of 49 policy documents from a public Kaggle dataset, which is a collection of organizational policy and procedure documents created to represent the complete policy library of a hypothetical healthcare organization. So here, the documents are chunked into 500 character segments, embedded using the pre-trained model tagged with role-based access metadata. Additionally, the system collects the query logs and evaluation metrics for analysis. The data analysis. To evaluate the system, I used a combination of real user queries and validation queries with a reference answer. A total of 81 queries were processed along with the 7 curated validation questions. The system was evaluated using several metrics: validation accuracy using cosine similarity, query success rate, and weighted precision based on user feedback, F1 score, and response latency across different stages. So the analysis also measured performance at each stage of pipeline, including embeddings, retrieval, and language model generation. This allowed us to understand not only the accuracy of the system, but also its efficiency and real-world usability. Now let me show the demo of my project. I hope my screen is visible again. So this is my policy system. I have logged in as an admin. So in my policy system, I have used admin, where he is the one who maintains the users documents and documents and manages the users. So this is the admin dashboard, where it has the chat, users, documents, dashboard, and profile page. So this is the chat interface. In the left, you can see the history of the chat which have been queried in the system. And this is the this is the chat interface where you can ask the query to the system. So I have two options here. So one is executive summary, another one is detailed. So executive summary gives a short gist of on pushing response on which you are queried for. It doesn't provide citation or references in here. Just a quick overview of the information from the database. And in whereas in detailed, it shows the in-text citation with the quoted reference. So the user can also check when go and check the policy documents so that they could cross-check and verify whether the policy is the generated answer is correct or not. So next is the user dashboard. Here the admin can create a new user and assign a role here. So another important feature is that the only the admin has the access to upload the documents. So he is the one who stores the document policy and assign the roles here. So here he can upload the document and then assign the roles. So these are the all the documents which I have from the Kaggle dataset which I have uploaded here and assigned some roles. So the here is the important feature. The admin has the access so that he can evaluate the system here. So this is the dashboard of the system activities and the alerts. So here we have the metrics, feedback, and validation and flag conversation. So in the metrics, as you could see, it shows like how many total queries have been passed through here, and how many success rate it has, and it also calculate apart from their user respective domain if they have accessed the other resources. They it has been calculated under the cross domain. And here we have all. I have also calculated the latency breakdown. So it will be like when the user hit query. So how much time will it take to generate the response? This is what I have calculated here. So yeah, then in the feedback, this is nothing about like in the chat interface, you will be having the thumbs up and the thumbs down option. So here, if we enter the thumbs up, this is for the user validation. If they are satisfied with the response, they could hit the thumbs up uh, to make sure that the given response is correct or not. So if not, they could click on the thumbs down button and then enter the description here. So that will be come here under the flagged conversation. So here the admin can see like why or from which of why this problem has been occurred, and then he could resolve it. So this is the validation run. This is what I have used for to. This is one of the use case which I have used for to like check how my system is working. So these are the 7 golden standard which I have created, or else a validation set. I have created, generated the questions and assigned the domains. And here in the expected answer, this is like I want like my system to generate a response, something like this. So I have set a standard. So after running it, from the total of 7 validation sets, the 5 of them have passed and the 2 of them have failed. But if you could see, like there is not much difference, but a slight fine tuning of the responses based on the golden standard. So yeah. Then is the profile page where it shows the logged in user profile account, and then here they can also set the default format response, like if they want the executive or the detailed summary.
Are you
Oh,
done, Aarti, or like do you
no,
need
no.
help?
Sorry, almost done. Just give me 5 more minutes.
Sure. Okay.
Yeah.
Okay. Okay. Okay.
So here I have logged in as a compliance user. As I mentioned, this is from like the user who was working here. So here I have, they only have the access to the chat page and the profile page. So the system supports the two type of differences, as I mentioned, like executive and the detailed summary. So let me hit a query and select the summary option. So here, as you can see, the executive summary, it provides a concise and clear answer highlighting the key points related to the query. The key feature of this system is the, as I mentioned, is the RBAC, role-based access control. To demonstrate this, I have now asked a compliance user related to the pharmaceutical policies based on pharmacy policies. So as shown, the system returns a controlled response indicating the user does not have the access to this information and is restricted to the authorized domain. Then another option is the detailed response. I'll show that too. Here I have hit the query and I've chosen the detailed option. In this case, the system generates more comprehensive answer along with citation from the source documents, allowing user to verify information. So this demonstrates how the system ensures both accurate information retrieval and secure access control. So, so my system has achieved a 91% of success query rate. It performed well for the structured queries like numeric policies, but struggled slightly with the procedural queries due to distributed content. So importantly, the access control mechanism work perfectly blocking all the unauthorized queries. One key observation is that the LLM generation dominates latency, accounting over 98% of response time. So this is due to the CPU-based local interface, not a design flaw. With GPU support, the response time can drop significantly. Overall, the system demonstrates strong real-world applicability with secure and accurate retrieval. So to conclude, this project developed a retail augmented documentation question answering system for organizational knowledge management. The system enables users to ask natural language questions and receive accurate, context-aware answers grounded to source documents. Um, the evaluation result shows the strong performance with the 91% success rate and the FN score of 80%. Overall, the system demonstrates the RAG approach can significantly improve the enterprise knowledge access while maintaining security, transparency, and usability. There are several areas for future improvement. First, the response latency can be reduced by the GPU-based interference instead of the CPU-based processing. Second is the retrieval quality can be improved by using the hybrid search method that combine the semantic search with the keyboard-based techniques. Third is by improving chunking strategies can be help better complex
Hi,
queries
I
where
thought I heard somebody.
yes. Okay, could I go on?
Yeah, yeah, continue.
Okay. Okay. So the third is by improving the chunking strategies can help better handling complex queries where information is spread across multiple documents. Finally, conducting large-scale user studies. Here, I have done with the 25 users or something. So, if the large-scale user studies and the testing with the bigger document collection would help evaluate this system real-world impact and scalability. So these are the reference I have used for this project. And thank you for this opportunity given for me. So I'm happy to take any questions.
So what software tools have you used on policy systems?
For the policy systems, I have used the Python as the background and the ChromaDB for the vector database, and then Olama, like Llama 3 is for the LLM module.
Oh, Okay, Arti. That's only my question. Well, congrats. Yeah. Nice. Okay.
Thank you.
Thank you so much, Aarti. I really don't have any questions for you. Once again, a big congratulations. Is there anyone in the chair who has any questions for Aarti?
Yeah, no more questions.
Okay, thank you so much for having this entire presentation and staying with me for the session number four. I think you guys should move on to the main session, the main room, which is session one, if it is on. Otherwise, you are good for the day. And yeah, thank you so much for joining the CS 687 capstone for the winter quarter 2026.
Okay. Thank you, Rajit, and thank you, everyone.
Thank
Wish you
you.
all
Yeah.
the
Thank
best.
you.
Yeah.
Guys,
Thank
bye
you,
bye.
everyone.
Take care.
Yeah. Bye bye. Thank you,
Take care,
Harrison.
everybody. Take care, everybody.
Thank
Yeah,
you.
big thank you to you, Harrison. See you soon, man. I'm going today. Bye
Uh,
bye.